The Big Bang Theory is known as the best concept about the origins of the universe. Today, astrophysics have shown that the theory accurately matches the phenomena observed in the universe for centuries. It has been a solid foundation that helps us understand how the universe formed 13.7 billion years ago. It all began with the Big Bang Theory, which holds that everything came to life all at once. The problem is that everything before the Big Bang is impossible to understand. However, popular scientific publications on the James Webb Space Telescope photographs claim that the Big Bang never happened, generating panic among cosmologists. How do these images suggest the inaccuracy of the Big Bang Theory? Let's decipher the evidence presented by the telescope itself to clear up any doubts. The potential benefits of the James Webb Space Telescope far outweigh the risks associated with this launch. No other scientific instrument has held so much promise for advancing our understanding of the cosmos. Scientists around the world have been eagerly awaiting their turn to use the telescope since it was declared operational. What none of them expected were such shocking discoveries. In less than 2 months of being operational, the James Webb Space Telescope has already captured images that contradict the Big Bang Theory. The understanding that the universe was born with a Big Bang is intrinsically ingrained in the imagination of millions of human beings. However, this theory is not as solid as most people believe. Many scientists, including atheists and naturalists, recognize that the theory has serious flaws, and the latest photographs provided by the James Webb Space Telescope have perplexed those who firmly believe in the Big Bang Theory. The Big Bang Theory grew out of the work of George Lemaitre, a priest-turned astronomer who in 1927 proposed that the universe began as a single point. He claimed that the entire universe had expanded to its present size and could continue to do so forever. A few years later, Edwin Hubble, after whom the Hubble Space Telescope is named, improved Lemaitre theory. Hubble revealed that other galaxies were moving away from us, and the distant galaxies were moving faster than nearby galaxies. Consequently, the astronomer concluded that the universe was still expanding, just as Lemaitre had predicted. If everything was moving away, it meant that everything was close together before. According to the Big Bang Theory, the cosmos originated as a collection of tiny hot particles intermingled with light and energy. As energy grew and took up more space, the temperature dropped and the tiny particles clumped together to form atoms, which in turn clumped together to form the stars and galaxies we see today. These early stars produced larger atoms and atomic clumps, and new stars were born. Galaxies collided and merged together, creating an incredible cosmic spectacle. Other objects such as asteroids, comets, planets, and black holes arose as new stars formed and parented. All this process happened over the course of 14 billion years. But what if the Big Bang didn't happen? Most scientists don't want to explore this idea because it has been a cornerstone of modern astronomy. However, the James Webb Space Telescope has generated a bit of chaos with its recent photographs. Right now, cosmologists all over the world are trying to explain why the James Webb Telescope images don't match the Big Bang Theory. The James Webb Space Telescope is meant to look at the infrared wavelengths of the electromagnetic spectrum, since light from very distant galaxies passes into this region of the spectrum. Our legendary telescope should be able to capture more detailed pictures of these galaxies. According to the Big Bang Theory, the light emitted by the most distant galaxies took more than 13 billion years to reach the Earth. According to this famous theory, we should see these incredibly distant galaxies not as they are now, but as they were more than 13 billion years ago. As a result, we should see the galaxies in their formation process even when they were not fully evolved. However, this expectation is often challenged, and preliminary tests from the James Webb confirm the pattern. Initial results from the James Webb Space Telescope seem to imply that large bright galaxies developed before the alleged Big Bang. If proven, this will radically challenge current cosmological beliefs. Many of these galaxies appear to be more massive than the traditional cosmological model, which defies the composition and development of the universe. To be fair, these are only preliminary results that have not yet been validated, but they are clearly generating anxiety among Big Bang theorists. I'm slightly concerned that we will find these galaxies in the James Webb images, said cosmologist Richard Ellis. The images shown by the James Webb Space Telescope have a flaw. They show an unusually large number of smooth, compact, and ancient galaxies. This seems to contradict the Big Bang theory. But why consider a very narrow point of view if the cosmos is expanding? We are seeing a strange optical illusion in reality. Galaxies and other naturally occurring space objects do not appear to decrease in apparent size as one moves away from them. They should increase in size exponentially above a certain threshold. Think about this. Galaxies get closer as one moves away from the visible brightness. This contrasts with how things look in unexpanded space, where distance has the opposite effect, and objects appear smaller as they get farther away. There's no denying that scientists who have analyzed the Webb images have discovered small galaxies. When compared to the Hubble images, galaxies with a brightness and mass greater than that of the Milky Way appear to be 2 or 3 times smaller. In these images, this kind of activity from an expanding universe is quite unexpected. If the universe is not expanding, the galaxies observed by the JWST are the same size as the galaxies closest to us, and the redshift is proportional to the distance. According to the Big Bang hypothesis, these very distant galaxies must be, in essence, unusually smaller to explain the supposed optical illusion. The strange observation challenges our current conceptions of the evolution and structure of the universe. If distant galaxies appear to be considerably smaller than expected, it opens up a new field of study in cosmology. Scientists are now engaged in heated debates about the possible implications of this unexpected phenomenon. Some theorists suggest that this apparent discrepancy in galaxy size could indicate variability in the fundamental laws of physics on cosmic scales, raising questions about the accuracy of our current models. Others propose that there may be unknown factors or phenomena not yet understood that could explain this apparent decrease in size of distant galaxies observed by the JWST. The possibility that our theories about the expansion of the universe and the evolution of galaxy are incomplete or wrong has ignited fervent interest in the scientific community. The James Webb Space Telescope mission has become a beacon illuminating the deepest mysteries of the cosmos, challenging us to re-examine and reframe our fundamental understandings of how the universe works. In the meantime, astronomers continue to meticulously analyze the JWST data in search of more evidence to shed light on this cosmic enigma, hoping that these discoveries will bring us one step closer to understanding the TR nature and evolution of the universe we inhabit. As the James Webb Space Telescope continues to collect and analyze data, the implications of its findings extend far beyond just questioning the Big Bang theory. These discoveries are forcing scientists to rethink not only the origin of the universe, but also the fundamental forces and laws that govern cosmic processes. The potential for new models of the universe, which may differ significantly from current ones, has sparked an exciting period of inquiry in astrophysics the possibility that galaxies are behaving in ways that contradict established theories suggests that our understanding of cosmology may be missing critical components. One of the intriguing aspects of these new observations is how they might reveal previously unknown phases of the universe's evolution if the galaxies observed by the James Webb Telescope are indeed more massive and compact than expected for their distances. It suggests that galaxy formation may have occurred much earlier than anticipated. This opens up the possibility that some cosmic events such as star formation and galactic mergers may have happened far sooner than the Big Bang Theory predicts. These revelations could reshape our understanding of the universe's timeline, suggesting that the cosmos may have been far more dynamic and complex in its early stages than previously thought. Moreover, the images from the James Webb Telescope are not just challenging the Big Bang Theory, but also the way we think about the structure of the universe. For instance, if these distant galaxies appear larger and more evolved than expected, it may imply that dark matter, dark energy, and other mysterious forces in the universe play a more intricate role than previously understood. The telescope's unprecedented view of the universe is also offering a deeper look into the atmospheres of exoplanets, which may give us insights into the conditions necessary for life to exist elsewhere in the cosmos. This broader context is vital because any shift in our understanding of the universe's formation and expansion could affect multiple fields of research, from the study of dark energy to the search for extraterrestrial life. As scientists continue to process the data, there will undoubtedly be debates over how best to interpret the findings. Some will argue that the new observations are simply anomalies that can be explained within the current framework of the Big Bang Theory. Others will push for the development of entirely new models to explain the evidence, leading to a potential paradigm shift in cosmology. What is clear is that the James Webb Space Telescope has already made a profound impact on our understanding of the universe, and its discoveries will shape the field of astrophysics for years to come.